In section 2 of unit 5, we're going to look at permutations and combinations. Okay, first we're going to look at permutations, and in permutations, here's the key thing. Order matters. You're arranging things in a specific order. Okay, so for number, we're going to do number 1 here first, and I have 3 letters, A, B, and C, and I'm going to take 2 of them, and it's asking to list all the possible permutations. So that would be all the possible orders of arranging 2 of them. So, and you kind of got to do this in an organized way. So I'm going to look at A. Let's say I took A and then followed by B. Okay, let's keep A in the first spot, but I could do A followed by C. Then let's look at taking B first, so I could do B followed by A, or I could do B followed by C. And then let's look at putting C, or taking C in the first spot. C could follow or be followed by A, and C could be followed by B. And there are then, so that's listing them all, and if you look at that, that is 6 possible permutations or ways to order 2 letters from A, B, and C, taken 2 at a time. Now, let's go down to number 4. So let me slide down here. And this is notation for permutations, and we have a formula for permutations. And it is this. So you're going to want to write this down. It's number of permutations, and we use an N and an R. Okay? So this is number of permutations or arrangements. N is always the total, so this is the total. R is the number you're arranging. So how many you are arranging out of that total. The formula says that is equal to N, oops, let's scribble that out, but it's N factorial all over N minus R in parentheses factorial. So let's review a little bit of factorial here first of all. Let me make my pen a little bit thicker for you. So if I have, for instance, if I have 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1. Okay? If I had 3 factorial, it's 3 times 2 times 1. And by the way, definition 0 factorial is defined to be 1, and that'll come into play sometimes. All right, so let's go down and look at number 4. I'm going to change it back to a little narrower marker. But we have the number of permutations, 7 total things, and we're going to arrange 4 of them. So this is just calculating how many arrangements there would be. So we're going to use our little formula. This is equal to N factorial. Well, this is my N, and this is my R, so it's 7 factorial all over N minus R, so it's 7 minus 4 factorial, which is really 7 factorial all over 3 factorial. Now, notice what 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's what I have on the top. On the bottom I have 3 times 2 times 1, 3 factorial. And if you notice, this cancels out. 3 times 2 times 1. So we're left with 7 times 6 times 5 times 4. And if you go ahead and do that, that equals 840. So, number of permutations, 7 items, arranging 4 of them, there would be 840.